Hello everyone, my name is Dr. Koka, and in this video we're going to be looking at how to clean glassware. I'll be using this beaker here to do the demonstration. So let's say we had a chemical in that beaker from a reaction that is finished, and now we want to discard the waste and clean the beaker. So the first thing we want to do is get rid of the chemical inside of that beaker. So depending on what it is, so for example, if it's a non-halogen organic compound, it would be disposed in an NHO container. So typically in our lab, we use this hood in the back as our waste station. We would have different types of waste containers in there, and you would go to the NHO container and dump the chemical inside of that waste container. So at this point, we would want to clean the glassware, and you could do that either in the waste hood or the sink next to it. But as I mentioned in another video, we don't want to discard any chemicals down the sink. So we would want to then proceed to add water to our beaker. So we can use a squeeze bottle that has water in it and squirt some of water into that beaker, and then go to an aqueous container, either the acidic or basic aqueous waste, dump that rinse into that container. Repeat this maybe a couple more times. And if there's anything that is soluble in water at this point, it should be gone from the beaker. So the next step is doing an acetone rinse. So acetone is a great solvent to wash the glassware because it's fairly inexpensive, and it dissolves most organic compounds. So we will want to do a rinse. And at this point, we will want to go to the NHO waste. So we want to move our funnel, if we have only one, to the second container. In this case, would be the NHO waste. And repeat this rinse a couple more times. Now, a thing about acetone is that it's more expensive than water, so we don't want to waste too much of it. So we want to do small rinses more so than we would with water. Acetone, as I mentioned, will dissolve most organic compounds, and it also dissolves water. So the water from the water rinses will also be removed with this acetone rinse. So that helps in drying the glassware because acetone has a much lower boiling point than water. So if you do just simply a water rinse, it might take a day or several days to dry the glassware by air drying. If we do an acetone rinse at the end, not only does that clean the organic compounds that are in the container, but it also dries the water and evaporates a lot faster than water. So probably within a couple hours, you could use the glassware again without worrying about acetone interfering with the next experiment. We can always dry the glassware with a paper towel if we're in a hurry to reuse that glassware in the same lab period. So that's also an option. Last thing is, if after doing the water and the acetone rinses, you find that there's still chemicals on your container, you could always use a physical method to remove that chemical. So a brush, for example. So you might want to put water again into your container and scrub your container until that chemical comes off. You could use a mix of water and soap. So typically by our sinks we have soap there as well that you can use. So you can use that plus the brushes, and that usually cleans the glassware pretty well. And then after following those rinses with water and the scrubbing, you will want to do one final rinse with acetone. If that doesn't work either, you want to talk to your instructor. There's other methods that we can use to clean glassware, such as sonication. So it's a method that sends sound waves through our container. So there's a special equipment for that, and that cleans glassware fairly well. And there's also a base bath that literally eats glass very, very slowly. That also will clean glassware very well. And that would be sort of an emergency use if the other things that I mentioned before don't work.